Hello everyone, welcome to Jaldi Academy. In this video we can learn the evaluation of integrals by the method of integration by substitution. Consider an integral I is equals to integration f of x into dx. The given integral is there in terms of x, that is I is equals to f of x into dx. We need to integrate with respect to the variable x. The given integral is, when the given integral is difficult, we will consider the transformation x is equals to g of t. We'll consider x is equals to g of t, and differentiating that with respect to t, we will get dx by dt is equals to g dash of t, and cross multiplying we will get dx is equals to g dash of t into dt. So now we have two transformation, one is for x, other one is for dx, and substituting x equal to g of t and dx is equals to g dash of t into dt, the given integral 1 takes the form I is equals to integration f of g of t into g dash of t into dt. The integral second one is simple compared to the given integral 1. On integrating the integral 2, we will get I is equals to f of t plus c. Say f of t is the integration of 2. Here the solution is there in terms of t. Now consider the transformation x is equals to g of t, and taking the inverse transformation we will get t is equals to g inverse of x. I is equals to f of, in the place of t we will replace it t as g inverse of x, that is the inverse transformation. We will get f of g inverse of x plus c. This is the value of the integral, given integral 1 in terms of x. Now we can solve few examples. Consider the first example. Example 1. Consider I is equals to integration of sin mx into dx. So to evaluate this, let us consider the transformation mx as some u, and differentiating we will get m into dx is equals to du. So and dx will take the form du by 2. So therefore, on substituting this mx as u and dx as du by 2, the given integral takes the form integration of sin u into du by 2. So here we will use the two properties. One is, if the integration is constant we can take it out, if the constant is multiplied we can take it outside the integral. So this can be written as 1 by 2 times integration of sin u into du. So we know that integration of sin x into dx is equals to minus cos x plus some constant c. So with that we will get 1 by 2 times minus cos x, here u is there, we'll get cos u plus some constant, say it as c1, and simplifying this you'll get to minus cos u by 2, sorry it is du by m, plus c1 by m. So minus, here m is mx is u, and substituting it back we'll get minus cos mx by m plus some constant c, take it as I. So this is the value of the given integral, where c is some constant, so we here c is taken as c1 by m. So similarly we can write integration of cos mx into dx. On integrating this we'll get sin mx by m plus some constant c. So this is the first example. So next we can consider one more example. So consider the second example. Evaluate integration of tan power 4 root x into secant square root x divided by root x into dx. Solution. Consider the given integral. So what is the given integral? I is equals to integration of tan power 4 root x into secant square root x divided by root x into dx. So here this can be solved in two steps. Either we can take first step. So let us take root x as some transformation t. On differentiating this we will get 1 by 2 root x into dx is equals to, root x differentiation is 1 by 2 root x into dx is equals to dt. So here on sending the 1 by 2 to the RHS, it will become 2 times dt. And substituting this, the integral takes the form I is equals to integration of tan power 4 u, so tan power 4 t is a transformation, secant square t into this dx by root x is replaced by 2 times dt, so which is 2 times integration of tan power 4t into secant square t into dt. So this is the first step. Next is consider. So for the second step, so consider the transformation tan t as u. So put tan t as u and differentiating this, tan t differentiation is secant square t into dt is equals to du. So on substituting tan t as u and secant square t into dt as du, we will get I is equals to 2 times integration of tan power 4t is there, tan t is u, so the integral takes the form u power 4 into secant square t into dt is du. So to evaluate this, we know the integral. We know that integration of x power n into dx is x power n plus 1 by n plus 1. This is true for all the values of n when x is not equal to minus 1. So on integrating the u power 4 in a similar manner, for n equal to 4, we'll get 2 times u power 5 by 5 plus some constant c. So on substituting back u as 2 by 5, u is taken as tan t, tan per 5t plus c, but further the t is taken as tan inverse, sorry, t is taken as root x. So we will get 2 by 5 tan per 5 root x plus c. So this is the value of the given integral. I is equals to tan per 4 root x secant square x. So which is equals to 2 by 5 tan per 5 root x plus some constant c. So this is the value of the integral. Take down the third example. So evaluate or find the value of integral sine tan inverse x by 1 plus x square into dx. So solution: consider the given integral. I is equals to sine tan inverse x by 1 plus x square into dx. To make the next step simple, I will rewrite the same integral as integration sine tan inverse x into, I will send the denominator 1 plus x squared with the dx, so it will become dx by 1 plus x squared. So let us put tan inverse x as some t. On differentiating, we know that d by dx of tan inverse x is 1 by 1 plus x square. We know that d by dx of tan inverse x is equals to 1 by 1 plus x square. So on differentiating this, we will get dx by 1 plus x square is equals to dt. On substituting this, the integral takes the form I is equals to integration of sine of tan inverse is taken as t, so sine t into this entire dx by dt can be replaced, dx by 1 plus x square can be replaced by only dt, and we know that the integration of sine x into dx is minus cos x plus some constant c. So on integrating, here it is there in terms of t, cos t plus c. Substituting back the value of t as tan inverse x, that is whatever we consider, we'll get cos of tan inverse x plus c. So this is the value of the given integral. I is equals to integration of sine tan inverse x by 1 plus x square. With this this is the method how we evaluate the given integral by using the method of substitution. Now With the help of this integration by substitution, we can evaluate the sum of the integrals of the trigonometric functions. So first one, to find the evaluation of the trigonometric integrals, so consider what is the integration of tan x into dx. So for this, take integration of tan x into dx. To solve this, we know that tan x can be written as sin x by cos x. So the integral takes the form tan x is replaced by sin x by cos x into dx. Now consider the transformation. Put cos x is equals to some u, and differentiating cos x differentiation is minus sin x into dx is equals to du. So therefore the integral takes the form integration of numerator I will combine dx with a sin x and cos x. Here we have a transformation for cos x as u, and by sin x into dx can be written as minus du. So now this is minus du by this cos x will be replaced by just the transformation u, will get minus du by u, which is equals to minus 1 by u into du, and we know that integration of 1 by x into dx is equals to log of mod x plus some constant c. So minus is there, minus log of mod cos x mod u plus c. So consider the transformation u is cos x, so we can substitute back u as cos x plus c. So further the transformation is, we know the identity of the logarithm, that is m log n is equals to log n per m. So this is log minus cos x mod per minus 1 plus c. We know that 1 by cos x, that is the reciprocal of cos x, is the secant x. So which is equals to log cos x reciprocally can be replaced by just secant x. So mod secant x plus c. Therefore integration of tan x is log mod secant x plus c. So this is the integration of tan x. The integration of tan x can be obtained by the method of substitution. The remaining two standard integrals are integration of secant x into dx. So to find this, we need some computation. So secant x into, I will multiply it by secant x plus tan x divided by secant x plus tan x into dx. Integration. So denominator is same, secant x plus tan x. On multiplying the numerator, secant into secant is secant square x, secant x into tan x is secant x, tan x into dx. Now we need to substitute the transformation. Put the entire denominator secant x plus tan x, some transformation, say it as u, and differentiating we will get differentiate u with respect to x, that is du by dx. Here we have two trigonometric identities. We know that differentiation of secant x is secant x into tan x, and the differentiation of tan x is secant square x, and differentiating secant x differentiation is the secant x into tan x. Differentiation of tan x is secant square x. On cross multiplying, du is equals to secant x into tan x plus secant square x into dx. So on substituting the value of integral, that is secant x plus tan x is u, and secant x into tan x plus secant square x as just du, the integral takes the form, the entire denominator is just only u, so 1 by u, the numerator secant x plus secant x into tan x plus secant square x into dx can be just replaced by du. So on replacing that, we'll get as du. So again, just now we reminded the integration of 1 by x is log mod x plus c, so which is equals to log mod u plus c, so which is equals to log, substitute back u, that transformation is secant x plus tan x plus c. So this is the value of the integration of secant x into dx. So this is how the integration can be evaluated by using the integration by substitution. Thank you for watching. So in the next class, in the next video, we can evaluate few more integrals by using the integration method by integration by substitution. Thank you.